I picked up this phase linear 400 amplifier on eBay, and I'm going to restore it and make it work the best we can. It didn't come with a top, so I'm going to have to make something for the top. The rest looks pretty good. It's interesting though, the capacitors, and by the way, that's what's wrong with it. Those power caps are actually shorted, so it constantly blows fuses. But they weren't mounted. They're just kind of laying in there with some craft paper around them. I don't know if that's from the original manufacturing or what. All in all, it's not in too bad a shape. So I ordered some caps to replace those, and they're from DigiKey here. And they're good for 11,000 hours. They're a pretty good cap. So I'm going to replace those first and get that taken care of. And then we can start recapping the main printed circuit board. And that will take a little bit of doing because it all has to be unsoldered first. But right now I got to get these capacitors in. I ordered brackets with them also because I want them mounted. I don't want them just laying inside of the amplifier like the originals were. So that'll be the first thing to do here. Going to remove the printed circuit board. I wish there were plug connectors on it, but it's totally soldered in, so all the wires have to be removed one at a time, and they'll have to be put back later. I'm going to clean all of the pads, get them all cleaned off, so when it's time to put the wires back on, they'll be ready to go. Now we're back to getting those capacitors back in. Cleaning off the bridge rectifier, putting the transformer wires on. That's the two black wires. And now we get the capacitors installed. The copper strap at the top, which is the ground strap, is not the right size for these caps, so I'm going to have to do some modifications to that. And I'm going to basically just cut it and then overlap it and solder it, and then it'll be as good as new. Also got to replace some of the wiring because it's going to come out to be too short. So I'm going to replace these ground wires that go over to the speaker terminals directly off of the filter capacitors. And then there'll be nice fresh wiring going to the speaker terminals, and we'll minimize the losses as much as possible. So now we'll solder the strap, get it in place. So the power supply is pretty much finished, other than I'm going to need to work on the fuse sockets because one of them is broken. So we're going to work on that also pretty soon here, but I want to get this main wiring finished, so when the board's ready to go in, the other wiring going to the board and so on will all fit back into place. And then I'm going to come up with the output section and a meter board for this. I'm going to remove all the electrolytic capacitors off of this main board here and replace them, because chances are they are leaky or have dried out or have just flat out shorted. So we'll just change all of them, and they're not very expensive, so we might as well do them all, and that'll help out quite a bit, I'm sure. Then it'll be the transistors. Transistors 1 and 2 need to be matched. So I'm going to take a handful of transistors and try the best match, I'm going to need 2 match pairs, one for left, one for right channel. I'm going to measure each one for the gain, or HFE reading, and I need to find 2 and 2 matched, or very, very close as possible for that differential pair on the front end of the amplifier. So I'm going to go through all of these transistors until I can at least find 2 matched times 2 for the left and right channels, and should always do this for this type of amplifier. I found 2 that are pretty close, so it looks like we've got 4 transistors that are going to work, and got them paired up and labeled, and should be ready to place them in the amplifier. I've labeled on the schematic all the original transistors and where they're placed here. They have a transistor chart here. I found that the 1305 and the 1304 are complementary germaniums, and those are not easy to find, but luckily these were good, so there's no problems there. I pulled out these just to measure them and see how close they were to matched. So I'll be doing that. I've replaced these 2 here with 2N5210s, which I matched for left and right channels, so I had to come up with 2 sets of match pairs. This TIS 93, I made an MPSA 93, so both of these are matched. Pretty close anyway. They don't have to be as matched as these do here on the input. And all the rest of these tested out okay, and it even has the original PL909 output transistors that Phase Linear had put in there originally, and they're all good. And then all these caps are getting replaced. I'm going to replace all of these capacitors here. There's not that many, so might as well do them all. Okay, I'm going to pull out all the old transistors in the preamp area of the PCB and just do some preliminary tests, see how far off the gain is of these transistors. And it looks like they're pretty much all over the place, so we're definitely going to replace them with the ones I discussed earlier. Alright, I'm going to start putting these transistors in the board. Start with the differential pair in the front, put the matched transistors in, make sure they go in the right spots, and then I will add the MPSA 93s for the other transistors, and once this is done I do the capacitors, and we're going to form the leads there and get the capacitors mounted in, and then it'll be totally recapped and ready to go. Once all the capacitors are in place, got to remember to put the heat sinks on the T05 transistors, make sure they're put back, and we're ready for the next step. Going to reconnect the printed circuit board to the main unit. Got to resolder all of these wires back in the right place, and get this printed circuit board back mounted into the chassis itself. Going to double check the wiring with this diagram here, make sure all the colors in the right spot. Also got the fuse holders repaired. Going to put some heat shrink on the ends here so they're not exposed so much, and then we're ready for the next step. This is the original lamp board for the VU meters, and I want to redesign it to take LEDs, and I figure it'd be best just to come up with a brand new PCB for this. This is the original VU meter circuit. Basically this output is from the speaker output. Then it comes up to the light board that lights up the meters through this 13K, through this diode, and then right to the VU meter. So the meters not really measuring anything accurate. It's just showing a signal going to the speaker output. So I have to come up with this circuit to place on the new light board. Also, I want to put some back-to-back diodes across this VU meter, because if this output ever to go DC very far, it could blow this meter. So we want to protect the meter also. So I come up with a schematic. The original, just to go back here real quick, the original lights are here on 6 volts AC to light the meters. The LEDs will be DC, so I've got to convert this 6 volts AC to DC. So that makes the board a little bit more complicated. I just used a simple bridge rectifier off the 6.3 volts. A little filtering, made the voltage accessible here just in case you want to take a meter reading or something, and then the LEDs will go across these pins here. And then this is the driver for the left and right VU meters. The rectification, I put a little bit of filtering here to soften the meters, to dampen them, and then the back-to-back diodes to protect the meter from any DC spikes that might come in here. Here's the board. It's a very long board. The LEDs will mount here. There's 4 per side. I got a screw terminal. I had to split the board here in half because the manufacturer said it was too long. This is maybe a little bit better look at it. So this is the board that I'm going to have manufactured. Okay, got the boards in. It's going to be 2 pieces. Otherwise I'd have to panelize them because they're so long, and that was quite a bit more cost to do that, plus more boards than I needed. So we went with 2 pieces that I have to connect together, and I'm going to solder the center together here, and then there's a couple small pads that have to be bridged also, and then the board will be all one piece. Okay, we're ready to mount the board onto the meters. I had to put an S-curve, so to speak, in the LEDs in order to get them to line up correctly and beam the correct way. Now we're going to screw this board down. Now I'm placing the wires, soldering the wires to the meter itself into the board. And once that's done, we can wire the board up to the main chassis of the power amp, and it should be ready to go. So now I'm going to test it, just see what the illumination is like. The LEDs are 2700K light temperature. That should look kind of like the incandescent bulbs. I wanted to come up with a protection circuit for the speakers in case something shorts in this amplifier and puts a DC rail out onto the speaker. Relays I would like to use because I could control the on and off timings, because when you shut off this particular phase linear amplifier and the filter capacitors discharge down here, it tends to pop, put a pretty good pop out. Doesn't hurt the speakers, but it's kind of annoying to listen to. So you could cure that with a relay. But I have run into many problems with relays and speaker outputs. I have 3 receivers I got out of the recycle bin. All 3 had issues with the relay on the speaker. Either one channel was distorted, both channels were dead. So on all of these units, I had to take them apart and clean the relays, take the relay covers off and so on, and then everything started working again. So I really don't want to put relays in the speaker outputs. But I did get 3 good receivers that people threw away because of the issue. I decided to go with the crowbar method to protect the speakers from the amplifier going into DC mode. This is a little circuit I got out of a PV-CS800 I was looking at. Of course, they got these reversed. Red should be the plus and black should be minus, but in any event, this uses a trigger to a Triad from this thyristor here. I picked one here that has pretty low current, so I can keep these impedances kind of high here, and this capacitor somewhat low. But these seem to be set for around 30 hertz, which is way too high. It needs to have a lot longer timing than that. I found this device here, which only needs 200 microamps to trigger, and it's pretty widely available, not very expensive, about $1.15 or so. I'm going to be using that to place in this circuit here I've come up with. So this will trigger the Triad here if the DC gets put out here from the amplifier in case there's a malfunction and either of the supply rails ends up popping out here to the speaker. This will clamp it and blow this fuse. So that's the way around the relay and still protect the speaker. I also added this LR network. Amplifier didn't have that installed either, so that helps keep some RF that might come back in there and cause oscillations. So I have this timing set where it is just shy of 100 milliseconds, which will put it at 10 hertz. So the amplifier should operate safely in the normal audio area without triggering this thing falsely. We're going to try to build up a board for this, see if it'll work out. It should work out fine. I've got a board here, and I made it where it can actually solder right to the banana plugs coming out the back of the amplifier. Everything fit on here, so it should be fine in the amplifier, and then we'll run some tests on it. I got the PCBs in. I'm going to build up on one of them, just this part here, to run some tests. I'm going to put a light bulb here in series and then put 60 volts in. When I apply the 60 volts DC, positive and negative, this should clamp and light the light bulb, and the voltage out here should go to 0. That's what we're hoping for. And then with a switch, push button switch, I'm going to trigger the oscilloscope and see what timing this has to activate and put the clamp across the speaker output. I built up a little circuit just for the clamp on one of the proto boards to do some testing with. Now when I push the button, the voltage goes to a certain spot after about 98 milliseconds. Positive. We're doing the positive rail at the moment. And if you notice, the top meter clamps down. That's connected to the speaker output, and it clamps down right away after about 95 milliseconds or so. Now we're going to do the negative, and that should work about the same. So if the negative rail is an issue, it will go negative and clamp down at about the same amount of time, which it is. And the meter here, the top meter, clamps to 0 when DC is applied to the clamp. This is the threshold detection. I'm slowly bringing the DC up, and it'll hit a certain point and clamp and go down to near 0. The 0.8 is the diode drop that's across the thyristor. I'm going to get the parts placed on the board here for the protection circuit and also the output filter that the original design did not have. So I added that to the board along with the Triad clamp circuit, and we'll get all this built up and put into the phase linear 400 amplifier. It's going to mount directly to the binding post on the back side. I lined the holes up in the board so it would match up to the banana plugs on the back. So that will actually hold the board in place. It should be snug right up there into the corner with all the wiring and everything attached. So it looks like it should work out pretty well. Here I'm going to do the light bulb test because it's ready to power up for the first time. I don't have the meter board on it yet, but I'm going to apply 120 volts and make sure there's no shorts. And it looks pretty good. The light bulb isn't lighting hardly at all. So we're in good shape there with the light bulb test. Now I'm going to check offsets. Clip onto what would be the speaker output, only I'm clipping on right at the transistor. These red potentiometers are there for adjusting the DC offset on the output. And it's at 0.3, which is no problem at all, so I'm not even going to readjust them, at least on that channel. We'll take a look at the other channel, and it's about the same. So 0.3 volt DC out the speaker output is negligible, so we're going to just stick with it the way it is. Okay, these two green resistors are my loads. They are 5 ohms. They're not 4 ohms, but they're 5 ohms, which will do fine. So we're going to get the oscillator ready to go here at 1,000 cycles. And I'm going to first test the amp at full output. There's clipping right there, and we're just below clipping, and we'll take the RMS output voltage here, and if we square that and divide it by 5 ohms, it comes out to 320 watts. And of course the meters are pinned at that point. The next test will be at full VU, which comes out to around 30 volts RMS. If divide that squared by 5 ohms is 180 watts. And then we'll try it at 0 VU, and that's at 21 volts. And that comes out to 88 watts. So the amplifier is working quite well. I found some chrome handles at McMaster Carr that work very well on the amplifier for the front panel. They look pretty nice, so here's the part number. It's a 11665A42. If anybody's interested in handles on the front panel of the Phase Linear 400. So I've got it mounted in the rack, or at least sitting in there for now. Going to run it with these other amplifiers. It's a 4-way system, so got the SAE in here and a Gallian-Kruger, a couple of other vintage old amplifiers. So we're going to give it a shot over time and see how it works out.